This is Spectrum Defender Model 3863. And if you're watching this video, there's a good chance you already have a datasheet for this instrument. So I'm not going to go through the datasheet with you. I've been reading those things forever, and I've always found that you can go through all the facts and figures on the datasheet and still not understand what the instrument actually does and if it's any good or not. So we're going to dig into some aspects of Spectrum Defender which may not be so obvious from the datasheet. Let's start by talking about what this instrument does. This is a 2-channel RF recorder and player. That means this instrument can capture 2 different blocks of RF spectrum at the same time. For example, you could capture one signal in the UHF band while simultaneously capturing another signal in the microwave region. These captures are a high-fidelity, gap-free record of all the signals present in those parts of the spectrum. All of the signals, noise, and interference in those bands are captured. You don't need to know in advance what kind of signals you're looking for. Spectrum Defender will capture everything. Now, after you've recorded some signals, you can play them back, either virtually to a computer screen or to physical RF output ports. When you play a signal to an RF output port, you can recreate the original electromagnetic spectrum on demand. When you play a signal virtually to a computer screen, you can slow it down and pause it, much like you might do while watching a YouTube video or slow motion sports replay. So how is Spectrum Defender used by engineers? Well, RF signals in the real world are extremely dynamic. They can disappear and reappear in a few hundred microseconds, change amplitude unexpectedly, or flutter with multipath. And these changes happen faster than the human eye can track. A traditional spectrum analyzer can't keep up with constantly changing signals. But Spectrum Defender doesn't miss a nanosecond. When you use this instrument to record the spectrum, you will be certain that you've captured everything that happened. You'll be able to count the radar pulses, catch every bit of interference, or watch the multipath ripple through your signal. This instrument is about truth and certainty. If you need to know everything that happens in the spectrum, then Spectrum Defender will deliver exactly that. One of the best parts of the RF recording test methodology is how it allows you to collaborate with teams. Instead of an RF signal existing in only one lab for a few hundred microseconds, an RF recorder allows you to capture that signal permanently and share it with colleagues anywhere in the world. We specifically designed Spectrum Defender to support this type of collaborative workflow. It's very easy to quickly export recordings to either a high-speed network or a high-capacity storage device. So the next time you capture an unusual signal, you won't be limited to just writing about it in an academic paper. You'll be able to share the original recording. If you've worked in the EW industry for any amount of time, you've probably noticed that the industry is full of weird niche test equipment. It's often built using one-of-a-kind hardware that's hard to support over a long life. Many times there's only 1 or 2 engineers that really understand how the hardware works. And when they retire, that's it. The hardware is unsupported. So that's why we don't do that with our Spectrum Defender instruments. These instruments are built using mainstream, high-volume hardware modules from National Instruments. These NI modules are designed for many different defense applications, not just RF recording. And because these modules are used in so many different programs, they have long life support. Our customers won't be stuck with an unsupported hardware platform. Now, the other great part of this design approach is that the instrument behavior is defined by software. And it's software that we can tailor just for you. So you get the benefits of both mainstream, stable hardware and the flexibility of software designed exactly for your workflow. Let's take a minute and talk about the connector panel for Model 3863. So as you can see, there's 4 main sections. We have an interface and control section, high-speed data transfer section, timing and sync section, and then RF input and output section. So the control interfaces are typical computer interfaces. We have USB for keyboard and mouse, display port for a monitor, and a couple of gigabit Ethernet ports for connection to some sort of control network that you might have in your facility. The high-speed data transfer allows you to quickly export files over a variety of different interfaces. So we have two 10 gigabit Ethernet ports. These are set up for multi-mode fiber right now. You could also set them up for single mode if you want. We have two USB 3.2 Gen 1 ports and one Thunderbolt 2 port. So these, would typically be used for connecting to some sort of high-speed storage network in your facility, or maybe a standalone SAN or NAS of some sort. And then the USB and Thunderbolt would typically be used to connect to an external SSD. The timing section is particularly important for radar applications. So we have two different time sources, or the system will accept two different time sources. It can accept either GPS time from a GPS antenna, or it can accept iRig time from an in-house iRig facility, or iRig timecode generator. Both of these time sources can drive the triggering circuitry of Model 3863, so you can record at a specific time. There's also an external pulse input. It'll trigger on either a leading or falling edge. It's 5-volt tolerant. And finally, we have 10 megahertz reference input for synchronizing the time base of the system to your house standard. Finally, we have the RF input and output section. We have two RF inputs on 23 gigahertz compatible SMA connectors and two RF outputs on the same. Finally, if you're not interested or you don't want to connect your own external keyboard and mouse, the system also includes a built-in KVM drawer. Let's spend a minute going over some of the major components of Model 3863. So in every RF recording system, you have an RF processing units, and then you have high-speed data storage units. So in Model 3863, the heart of the RF instrumentation is two NI Model 5842 VSTs. These are signal generators and analyzers, channel 2, channel 1. And there's also a timing and sync card. These are rated from essentially DC 50 megahertz, I believe, up to 23.5 gigahertz. So this is the heart of the RF capture circuitry. Now, the other side of an RF recorder player is the high-speed data processing. So here we have two SSD modules. Each of these is 16 terabytes, which is frankly a modest amount of capacity, but they're very, very high speed. So these are each capable of recording 5 gigabytes per second, which is what's needed to record 1 gigahertz of RF bandwidth on each channel. So channel 2 spits out 5 gigabytes per second of IQ data, which is streamed to this SSD disk array. Same thing with channel 1. Now, once those high-speed data recordings are on the SSDs, after the recording is finished, you can copy them to this archival disk array. Now, this particular configuration has 12 18 terabyte spinning disks, so that's a total of 216 terabytes of capacity unformatted. So we can quickly copy data from the SSDs that originally stored the data onto this archival storage system with up to 216 terabytes of storage. These disks are combined in a RAID set for high capacity storage, but it's also possible to exclude an individual drive from this RAID and reserve it as a standalone disk device. So then it's possible to copy a recording to an individual drive, remove it, and FedEx it anywhere in the world. So Model 3863 records 2 channels at a gigahertz each. Each of those channels produces 5 gigabytes per second of IQ data. So the system has to handle 10 gigabytes per second of raw IQ data. And not only does it have to store it on disks, but it has to transfer it across buses without dropping any data. So this requires a relatively sophisticated CPU and data transfer mechanism. Now in this machine, there are no external computers. The CPU is built in here to slot 1 of this PXI chassis. This is a specially rated processor that is able to handle 10 gigabytes per second of IQ data from the RF VSTs to and from the SSDs. Model 3863 has a built-in power sequencer. So when you push this big, beautiful green power button up here, this power sequencer turns on these instruments one by one in the correct order so that everything is recognized when the power sequence is finished. When it's time to shut the system down, push this button, shuts everything back down in the correct order. Spectrum Defender is designed to deliver the highest fidelity, the widest bandwidth, the longest record times, and the most channels. It's a long-term investment that will grow with you over time. This is premium grade instrumentation, and it has a price to match. This is not the cheap stuff. If you just want to record 10 megahertz in the VHF band, this is probably overkill for what you want to do. But if your job requires you to work with a variety of wideband signals all over the spectrum, Spectrum Defender is the tool you need.